Hi all, welcome to new class. Today's class is about decoders. A decoder is a logic circuit that converts n-bit binary input code into m output lines such that only one output line is activated for each one of the possible combinations of the input. So this is the general block diagram of a decoder with n input and a m output. And for each of the n input, there are 2 raised to n possible input combinations or codes. And for each of these input combinations, only one of the m output will be active high and all other output will remain inactive or low. And some decoders are designed to produce active low output while all the other output remain high. Let us study about 3 line to 8 line decoder. So here 3 line, that is 3 inputs are there. So there are 2 raised to 3, that is 8 possible input combinations are there. So here inputs A, B, C, that is 0, 0, 0, 0, 0, 1. These are the possible input combinations 0, 1, 0. So these are the possible combinations of the input. Then for the input corresponding to these 3, that is for these 8 input combinations, only one of the output is high at a time. That is for this combination, that is for 0, 0, 0, D0 will be high and all other output will be at active low. And then for 0, 0, 1, that is for this combination D1, that is only one output will be at high and all other combinations, all other output will be 0. Then for this D2 will be high and all other will be low. And for this D3 0, 0, 0, 0, 0, and for this, that is 1, 0, 0, D4 will be high and all other output will be 0. And for this D5 0, 0, 0, 0, 0, for this D6 all other will be at low, and for this D7 will be high and all other output will be at low. So this is the truth table for 3 line to 8 line decoder. And note that here this is MSB and this is LSB. Now we have to draw the logic diagram. To draw the logic diagram, first of all draw the binary inputs, that is A, B, C. A, B, C are the inputs. Then for D7 all the inputs are at a high. So to get the output D7, draw AND gate and all the inputs are at high. So this is D7 and that is equal to A, B, C. And for D6 it is A, B, C bar. So D6 equal to A, B, C bar. So for that we need C bar. that is a NOT gate here, C bar, then B, then A. And next is D5. For D5, it is A, B bar, C. A, B bar, C. So for that we need B bar, that is B bar. So here one NOT gate, then B bar. Next is A and C. So this is A. So we can draw like this, A, then C. So C we can draw from here, or here we can draw C. So like that, draw all the output combinations. That is, next is D4, and D4 we will get A, B bar, C bar. So A is here, that is A, B bar, so B bar here, then C bar. Next is D3, and D3 is A bar, B, C. For that we need a NOT gate here, A bar, then B, then C. C we have already taken here. Okay, B already we have taken from here, so take either from this to this, or draw like this. Then D2. D2 is A bar, B, C bar. So A bar is here, then B, C bar is this one. Next is D1, and D1 is A bar, B bar, C. D1 A bar, that is A bar is this one, B bar, so B bar is here, then C is this one, and last one is D0. D0 is equal to A bar, B bar, C bar, that is A bar is here, then B bar, C bar. So this is the logic diagram for 3-line to 8-line decoder. And it is called 3-line to 8-line decoder because it has 3 input lines and 8 output lines. And it is also called binary to octal decoder, because it takes 3-bit binary input code and activate only one of the 8 output corresponding to that code. And it is also called 1 of 8 decoder. 1 of 8 decoder because only one of the 8 output is activated at one time. And for active high outputs, AND gates are used, and for active low output, NAND gates are used. That is, for active high output AND gates are used, active low output NAND gates are used. Next is BCD to decimal decoder, or it is also called 4-line to 10-line decoder. Because in BCD number system, we know the numbers 0 to 9 are valid and from 10 to 15 are not valid. So it is called 4-line to 10-line decoder. And we can draw the truth table, that is input BCD code. Let A3, A2, A1, A0 be the inputs and output for the combination 0 0 0 0, let the output be D0 bar. That is, here we use active low notation for the output. Next combination 0 0 0 1 D1 bar. So here up to 1001 the output is there, and from 1010 to 1111 there will be no outputs. So this is the truth table for BCD to decimal decoder. Now we have to draw the logic diagram. So to draw the logic diagram, first of all draw the 4 inputs, BCD inputs, A3, A2, A1, A0, and first one is D0 bar. So for D0 bar, A3 bar, A2 bar, A1 bar, A0 bar, whole bar is needed. That is, here we are using NAND gate for the active low output. We are using NAND gate. So first one is D0 bar, and that is A3 bar, A2 bar, A1 bar, A0 bar, the whole bar. So for that we need A3 bar, A2 bar, A1 bar, A0 bar. So draw NOT gates here. So from here we can draw very easily. That is, this is A3 bar, then A2 bar, next A1 bar, then A0 bar. So this is D0 bar, and next is D1 bar. So D1 bar is here A3 bar, A2 bar, A1 bar, A0. A3 bar, A2 bar, A1 bar, A0, the whole bar. So A3 bar is this one. So from here we can draw A3 bar, A2 bar. A2 bar is this one. Then A1 bar is here. Next A0. So A0 we can take from here. So we will get a D1 bar. Like this all the output we can draw. So like that, draw every outputs. D8 bar. D8 bar is A3, A2 bar, A1 bar, A0 bar. So A3. A3 is from here we have to take A3, then A2 bar, A2 bar, A1 bar, then A0 bar, and last one is D9 bar. D9 bar is A3, A2 bar, A1 bar, A0 the whole bar. So A3 is this one, A2 bar, A2 bar, then A1 bar, A0. A0 is this one. So like this we have to draw the logic diagram for the BCD to decimal decoder or 4 line to 8 line decoder. So here for the input combinations that are invalid for BCD, none of the output will be activated, and it can be termed as 4 line to 10 line decoder or 1 of 10 decoder. 1 of 10 decoder. Thank you for watching the class. If you like the classes, please like, share with your friends and subscribe my channel.